Okay, we are now going to proceed with the second part of quadratic function, and well, this time we're going to talk about its graph. Let's proceed. So with part 2, we also have objectives. This should be done at the end of the lesson. At the end of the lesson, all of you will be able to graph quadratic function, identify the properties of the parabola, the vertex, the axis of symmetry, direction of the opening of the parabola, intercepts, domain, and the range. Analyze the effects of changing the values of a, h, k in the y equals a quantity square x minus h plus k of quadratic function on its graph. So we're now done with the objectives. Now, how do we graph a quadratic function? The graph of quadratic function is a parabola, as I have mentioned in the first part of our lesson. It has different properties including the vertex, the axis of symmetry, direction of opening of the parabola, x and y intercepts, domain, and the range. You will know all of these 7 or 6 parts of the properties of the parabola in this lesson. So first, in graphing quadratic function, we must identify the different properties. In this case, we will only identify the y-intercept instead of x and y-intercept because x-intercept is a separate lesson in this quadratic function. So again, in order to graph y is equals to 2x squared, you need a table of values. Okay? So, the graph of y equals 2x squared has the following points. Okay? All you have to do is to connect the dots. And then, let us now identify the vertex. The vertex of the parabola is the point hk. It is the minimum point of the parabola if a is greater than 0 and maximum point when a is less than 0. Since the value of our a here is 2 and it is greater than 0 as stated here, therefore, the vertex is found at the lowest point, okay? And the lowest point of the vertex is 0, 0. It is here. This is your vertex, okay? Since this is the lowest point of the parabola, minimum point or the lowest point of the parabola gives the vertex when a is greater than 0. Since a is positive 2 and it's greater than 0, the vertex is found at the lowest part of the parabola. And obviously, the opening of the parabola depends also on the value of a. If a is greater than 0 or if a is positive, then the parabola opens upward. Since the value of a here is positive, then the opening of the parabola is upward. It opens upward. But if your a is negative, the parabola opens downward. Take of these reminders or pointers. Then what is the axis of symmetry? The axis of symmetry is the vertical line x is equal to h, and it divides the parabola into 2 equal parts. See this red broken line here? In this parabola, this is what we call the axis of symmetry. Since it divides the parabola into 2 equal parts, the value of x in your vertex is considered the axis of symmetry. So take note that the coordinate pair begins with x and ends with y. So therefore, the axis of symmetry pertains to the value of x in the vertex. So x is equals to 0. Okay? Next, what is the y-intercept? The y-intercept is determined by setting x is equal to 0. So meaning to say, if we will let x be equal to 0 and we're going to solve for that, 2 times 0 squared. 0 squared is 0 times 2, therefore the value of y-intercept is 0. Again, to get the y-intercept, you'll just have to let the value of x in the equation be equal to 0 so that you can now find the value of y. And at the same time, if you have the graph of the quadratic function, which is the parabola, when the graph intersected the y-axis, then that's your y-intercept. So the graph or the parabola intersect the y-axis at this point, and this is your vertex. Just get the value of y in your vertex, and that would be your y-intercept. Again, this is only goes for this given because the y-intercept also is the vertex, but not all the time that the y-intercept is at the vertex. Now, what is domain? The domain will always be the set of all real numbers because the domain is your independent variable. Meaning to say, if you will set up a table of values, you can write any value of x and then solve for the value of y because x, or the domain, is the set of all real numbers and it's an independent variable. Now, range pertains to the value of y. Now, what would be the value of y in this parabola? The range, in this case, if a is greater than 0, our a here is greater than 0 because it's 2, the range is represented by a brace y such that y is greater than or equal to k. Take note, our vertex also means h and k. Okay? So what is the value of your k here? It's 0. So all you have to do is to replace this one with 0. So again, the range is y such that y is greater than or equal to 0. We're following this format because the value of a is greater than 0. But if a is less than 0, if this is negative, then you will follow this format for the range of the quadratic function. Okay, now, is it possible for us to identify the different properties of the quadratic function without the parabola itself, just by the use of this vertex form or general form? Yes, this is possible. All you have to do is to identify this and look at the formula or the equation. So we have y is equals to negative 2 times the quantity square x minus 1 plus 2. So what is the vertex? Take note that this is also called the vertex form because it can give you the vertex. Okay, so the vertex is 1 and 2. Since x minus 1 is equals to 0, transpose negative 1, that's why from negative 1 it is positive 2, and positive 1 rather, and then you'll have positive 2 here. That's your hk, but the sign changes for h. The opening of the parabola, since the value of a is negative, therefore the graph opens downward. The axis of symmetry pertains to the value of h. X is equals to h. So our h is 1, so x is equals to 1. The y-intercept now is, we're going to solve for it. All you have to do is to let x be equal to 0. So ito na po yun. This one, we do this one here by substituting x with 0 to get the value of y. So 0 minus 1 is negative 1. But negative 1 squared will give you positive 1. So negative 2 times 1 is negative 2 plus 2 equals 0. So the y-intercept is 0. The domain, like just what I've said in the previous example, will be the set of all real numbers. And the range, since this is less than negative rather or less than 0, you'll use less than or equal to and get the value of k from your vertex, and that is 2. So you'll have the braces y such that y is less than or equal to 2. Now how about this? Second example. We have y is equals to negative x squared plus 4. So we have here the vertex. Since you do not have a parenthesis like this one in the first example, therefore the value of your h is 0 and the value of your k is the constant term. Again, since you do not have the parenthesis, therefore there is no h, or h is 0. And the constant term would be the value of k, which is 0, 4. The opening of the graph, again, the value of your a is negative or less than 0. It opens downward. The axis of symmetry pertains to the value of h in your vertex, so x is equals to 0. The y-intercept, let's solve for it by letting x be equal to 0, and that is 0 squared is 0 plus 4 is 4. Domain, just like with this first example, is also the set of all real numbers. And lastly, the range, since this is also negative and less than, we will use the bracket y such that y is less than or equal to the value of k in the vertex, which is 4. Now, this is how you identify the different properties of quadratic function using equation and by using the graph. Okay. So, there was this question. What will happen to the graph of x squared if the value of h and k changes? So, I have here first y is equals to x squared and its graph. Okay? Then I have another one. Okay? So as you can notice, y equals the quantity square x minus 1 plus 1 comes from the graph of y equals x squared, because both of the values of a here is 1. And this is the graph. From this graph, from this black parabola, it moves to this red graph. How do we do that? What happened? Meaning to say, as h and k changes for the value of y equals x squared, there was a shifting in the parabola of x squared, and that is the graph of x squared shifted 1 unit to the right, okay, and 1 unit upward. How do we do this? We pertains to the value of h and k. Since the value of your h and k here is 1 and 1, while on x squared the value of hk is 0 and 0. So with that, how many times did the x or h moved from the origin? So it moved or shifted from 1 unit to the right, from this one, 1 unit to the right, and 1 unit upward. That's how the graph of x squared changes when we have a value for h and k. Another example. From the graph of y equals x squared, we'll now have y is equals to x plus 3 squared minus 4. So this is the graph. From the origin, from this black one, how many times did it move? If this is your vertex, so you'll count 1, 2, 3. 3 units to the left, and then 1, 2, 3, 4. 4 units downward. So the parabola here shifted to this part here with 3 units left and 4 units upward because the value of HK is negative 3 and 4. Again, HK means the vertex. Okay? And if it is inside the parentheses, you'll have to change the sign of your H. You'll have negative 4 here. And if the sign is negative, for K, it means it goes downward. If it's positive, it goes upward. Same thing happens with X. If the value of H, or rather, is negative, then it goes to the left. If it's positive, then it goes to the right. So, let's identify the transition of the graph of 2x squared when we have y is equals to 2x squared plus 4. So, in order for you to do that, you must identify the vertex first. Actually, this is not necessarily, but if you want to be sure with your answer, you can identify the vertex, and the vertex is 0 and 4. So with that, the transition is the graph of 2x squared shifted 4 units upward. Because the value of h is 0, it does not shift from left to right. Here, the value of hk is 3, 0. Therefore, the graph of 2x squared shifted 3 units to the right. Next, we have 2x plus 4 squared plus 7. The vertex is negative 4, 7. Okay, since this is negative, it is h. The graph of 2x squared shifted 4 units to the left and positive 7 units upward. And lastly, we have y is equals to 2x squared minus 1. The vertex or hk is 0 and negative 1. The graph of 2x squared shifted 1 unit downward. Okay? And lastly, we'll have this. What will happen to the graph of x squared if the value of a changes? So in this case, y equals x squared. The value of a here is 1. Right? And this is its graph or the parabola of x squared. Next, I have here y is equals to 2x squared. And this is the value of a is 2. Now notice the changes in graph. Can you tell me what happened to the graph? Okay, yes, that's correct. That is correct. Yes, the graph of y equals 2x squared has a smaller opening compared to the graph of y is equals to 2x squared. Let's have another example. Y equals 1/2 x squared. And the graph of y equals 1/2 x squared is this. Now, what can you say about this? It is already shown here. As the absolute value of a becomes greater than 1, like this one, which is 2, the narrower the parabola is. Ibig sabihin, pag mas malaki daw yung value ng a sa 1, mas maliit ang opening ng parabola. While, if the value of a becomes smaller than 1, just like with this one, the value of a is smaller than 1 because it is 1/2, the opening of the parabola becomes wider. So that is the effect of changing the value of a in the quadratic function. So this is all our lesson for today.